Do you like sweet smells? Do you like fruits? Do you have organic chemistry? Do you like it? I guess not. Well,
Are you used to writing level 1 answers for your chemistry test? Then this video is going to help you. Hello, my name is Vaibhav Bhattacharya and I am an excelling chemistry student. I am here to help you with all of your problems regarding organic chemistry. But today we'll be focusing on a specific family of organic chemistry known as esters. These are a family of organic compounds characterized by their sweet smelling nature. They are very frequently used in perfumes, so yeah, your perfume contains ester. Well, let's begin with identifying and drawing structures of an ester. The general formula of an ester is RCOOR prime, and if you're confused as to what this whole COR prime deal looks like, look right here. R represents an alkyl group. We should already know that. And there's an alkyl group bonded to a carbonyl group, which is then bonded to an oxygen group, which is then bonded to another alkyl group. And a better way of showing this, and this is what you'll probably be using most of the time, is R carbonyl group OR prime. So these are three different ways of showing general formulas of an ester. Now let's look at the complete structural diagram of an ester. I'm going to show all the carbons in a straight chain, then there's an oxygen and then a carbonyl group and then the other carbons. So an alkyl group, then which is bonded to an oxygen, which is bonded to a carbonyl group, which is then bonded to another alkyl group. Now, to fulfill the valence around each carbon, I show 3 or 2 hydrogens as per need. And around this oxygen, there is an electron domain geometry of bent due to 2 lone pairs over here. We're not going to get into that right now, but that's just how the molecule would look if we were to look at it in a 3D, in 3 dimensions. This is how you show an expanded formula for an ester, where instead of showing the bonds between the carbons and the hydrogens, you just condense that and write it as CH3, line CH2, but you still show the bonds between each carbon and or carbon hydrogen. So you still show the straight chain, but you don't show the hydrogens in the straight chain exactly. So CH3, line CH2, line O, line C, circular bracket O. This is how you show a carbonyl group in an expanded formula and a condensed formula, which is down over here. And then you just go on with the same deal. Over here, instead of, if you were to take the expanded formula and remove the bonds between the carbons and condense it and write it as is, that would be what we call a condensed formula. It just shows CH3, CH2, CH2O, C bracket O, CH2, 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 CH3. To show a line structural diagram, we're going to remove even the carbons now, and not show the carbons and the hydrogens, only show other atoms than carbons and hydrogens in the carbon chain. Over here, I show it as zigzag lines. This represents an alkyl group, which is bonded to an oxygen, and then a carbonyl group, which is then bonded to another alkyl group. Now, we show zigzag lines to represent the electron domain geometry around each carbon, which in these cases, because each carbon has either has 4 bonds around it, its electron domain geometry would be tetrahedral. So it kind of shows like a bent linear shape. Sorry, a bent zigzag line kind of shape. We can't really tell if it's an ester just by looking at its molecular formula, which for this ester is C8H16O2, because you can't tell whether there was a carbonyl bond in the middle and there's this whole RCOOR prime deal going on. You have to be provided with a line diagram or an expanded formula or a condensed formula or a complete structural diagram to know that it is an ester or identify it as an ester. Let's move to reactions now. Before I get into nomenclature of esters, I'm going to talk about reactions of esters. First type of reactions that esters are involved in is synthesis. So synthesis of esters. Now, esters are carboxylic acid derivatives because they're derived from a reaction that involves a carboxylic acid and an alcohol. So an alcohol plus carboxylic acid in the presence of our textbook catalyst, which is sulfuric acid, and heat, produce an ester. And over here, the alcohol has 1-propanol and pentanoic acid. So the part of the carboxylic of the ester that's after the carboxyl group is the part that came from the carboxylic acid, and this part that's before the oxygen over here, the alkyl group, that's the part that came from the alcohol. Now, the reverse reaction can happen too. It's called hydrolysis, where an ester is taken and in the presence of H plus or dilute acid, it splits back into its alcohol and carboxylic acid parents. This reaction happens where the ester is cleaved right where it was formed, and we get hydrogens attaching over here and a OH group attaching over here. Now let me explain to you exactly what happens over here. In this reaction, when I react an alcohol plus a carboxylic acid in the presence of sulfuric acid and heat, and a hydrogen is taken and this entire OH group is taken, they both combine and come off together as water, and this oxygen gets bonded to this carbon over here and condensing the entire molecule condensing the two molecules into one ester molecule. Now the exact opposite happens where during hydrolysis I'm taking water, which is basically HOH, and this breaks the bond, breaks where the ester was formed, so it cleaves right where it was formed. The hydrogen gets attached to the oxygen, and the OH groups gets attached right here to form the alcohol and the carboxylic acid. Now we're going to treat an ester as a human child, which will be named on both its parents, the carboxylic acid and the alcohol. Now let's talk about naming, also known as nomenclature of esters. So the main suffix you'll be adding in the name of an ester is OAte or dioate. First step, and here I have an example which I'll be using to kind of go along with my steps and name it as I go. First step, you number the longest chain of carbons starting at the carbonyl group and going away from the oxygen. So like this, you want to start at the carbonyl group and you want to number this chain of the carbon, not this one first. First you want to name this one, and first you want to number this one, going away from the oxygen. So 1, 2, 3, 4, 5, 6. Remember, this carbonyl group has to get the lowest number. So that gives me a root word of hex, and since suffix is OAte, because I only have one ester group over here, so hexanoate. And I have, then I'm going to identify any side groups on this part of the molecule, and I have phenyl group on number 4. So 4-phenyl hexanoate. That's my carboxylic acid part of the molecule that came from the carboxylic acid parent. Now I'm going to focus on the alcohol part of the molecule, or the other part of the molecule. I'm going to number from this side because I want to get the hydroxy group the lowest number. So 1, 2, 3, 4. That is 2, and then I want to name it as 2-hydroxy butyl. Let me rewrite that. So 2-hydroxybutyl 4-phenyl hexanoate. After I name the first half, which is from the carboxylic acid, I name the second half, which is from the alcohol parent. Now, general form for an ester, like the name, general form for the name will always be alkyl alkanoate. It'll always look like this, alkyl alkanoate. It could be propylbutanoate, butyl propanoate. And over here, as you can see that there's no dash over here. These are two separate parts of the name, as I was talking. The first part's from the alcohol parent, and the second part is from the carboxylic acid parent that formed this ester. I named the carboxylic acid parent because I wanna get my root and my suffix done and placed. Then I named the alcohol parent, and there's a space over here, so you write this name with a space, not with a dash. So there we go, 2-hydroxybutyl 4-phenyl hexanoate. My bad. Thank you for listening and watching, and have a good day.
But wait, now that you know quite a fair bit about esters, there is a worksheet linked in the description. Fill it out, print it out, and keep it as a reference for future purposes. Thank you.